Well, my name is Braulio Martinez. I'm a software engineer. I've been doing Ruby for the last 12 years. That's me on Twitter, GitHub, and Mastodon. Um, I'm also a co-founder of Cedar Code. We're a company that helps other engineering teams grow their teams in size and expertise. We have been doing quite some open source stuff since we began. But we got a small place in the huts for security related things. So that's why I'm here today to talk to you about WebAuthn. How can you go passwordless and by adding WebAuthn into your Ruby applications. This is the agenda that we will go through. First, why something like WebAuthn was born. Then the context, what it is, who developed it, and we will go through the workings, how it works internally, the different entities and stuff that it's in the standard, and a little bit of code. And then we'll talk a little bit about adoption, what companies use this kind of technology already, what platforms do support already, have support for WebAuthn, and try to encourage you all to take the step to add something like WebAuthn into your apps and leave you with a bunch of resources that could help you do that. So anyone that wants to design an authentication system needs to think about these so-called authenticator factors. There's 3 categories of them. Knowledge factors, which is something we know, for example, a password or a PIN. Possession factors, which is something we have, for example, a banking card or a security key. And inherent factors, which is something we are. For example, our fingerprint, our face, our voice, or a typing pattern we leave every time we type. Ideally, in an authentication system, we will have the 3 of them, but for some consumer applications, it might also be too much. If we talk, for example, about, well, daily examples that we see about on authentication system in our daily basis. For example, we got the ITM authentication. It has 2 factors. We got the banking card as a possession factor and a 4-digit PIN as a second factor. We, for example, could think about WhatsApp's authentication, and we will see that it has the possession of the mobile number, which is the first factor, a possession factor. And we could optionally also use a second factor using a knowledge factor of a 6-digit PIN. But the most common authentication factor or method we got for the last 34 years, it's passwords. Passwords are nothing else than a shared secret between us and the servers. But they are prone to many different types of attacks. Phishing attacks, brute force attacks. They live in a database and travel through a server, so they are prone to being if a hacker accesses the database or the server, they are going to have access to all of our users' passwords potentially. I know they're encrypted, but if they crack them down, they will have access to all of them at the same time. Users repeat passwords from one system to the other, so if a hacker gets access to a user's password in one place, they're probably going to try to use that in another place as well. And at the end of the day, they are really bad UX, both for users and us as developers. Like, users need to follow the rules we put to passwords, rotate them. They get frustrated every time they need to put a new password somewhere. For us developers, we need to filter them out from logs. We need to treat them carefully on how we store them. So it's a problem. They are not a good authentication method. 81% of all hacking-related breaches were a consequence of stolen passwords. There's the report there. You can tell me, okay, but nowadays we got a lot of good second factors. People are getting more used to things like that. The most used second authentication factors nowadays could be using OTP through SMSs. That's a method that it's actually discouraged by the US government and to its employees, for example. So it's a very lousy way of sharing a one-time password. It's prone to different types of attacks, like mobile transfers at the telecom level, interception at the infrastructure level, social engineering, and phishing and man-in-the-middle attacks are pretty common to hack things like SMSs. You can get a little bit better with time-based one-time passwords through Google Authenticator, Authy, or whatever application you want to use for that. They are also prone to different types of hacking techniques. Phishing attacks, same thing. Accessing your browser's cache and getting the QR code you use to set it up. It's another very common attack. And yeah, I mean, server clock manipulation, for example, as well. A hacker enters the server, makes a specific code work forever. They have their problems. On top of that, like only 28% of all users use some kind of second factor, which is a very low number. Another good number is that 89% of all organizations suffer at least one phishing attack in the course of 2022, with an average cost of a little bit more than $2 million. And after they got attacked, 64% of all those companies still kept using passwords as their only authentication method. For anyone that hasn't seen or experienced, luckily, a phishing or a replay attack, I put together a small example of how it would look. Let's say you get an email, says you need to access your Google account for any reason, you need to update something, whatever. You get a link in there, a button that tells you, directs you to the page to actually do that. And that pops up a small window that tells you to log into your Google account. That page seems pretty legit. The URL looks fine. The look and feel of that page is pretty Google. So you go ahead and you put your email, password. You are a cautious user, so you use a second factor. But if you take a real close look, the URL was actually, a piece of the URL was actually hidden. A very common attack is that they short down the viewport so you don't actually see the full URL when the window gets popped up. I know we are tech people and we think we won't fall into those kind of tricks, but yeah, anyways, we need to think of authentications for all the range of skill sets for all users. So you have probably fallen into an attack, and this is actually fakegoogle.com, and yeah, the hacker is going to replay whatever you put there. They have some time, 1 minute, to replay the authenticator code you just entered, so they'll probably get access to your real account. Moving on to what WebAuthn actually is, there's the formal definition of it. There's quite a few definitions out there that from different companies that have definitions of WebAuthn in their page. But what I try to do here, what you're gonna read, it's my version of it that tries to explain it in a very minimalistic and simple words. For me, WebAuthn is just it's a standard that defines a set of rules for APIs to enable users to strongly register and authenticate on web applications using public key-based cryptography. The people that created it are the W3C, the organization that defines web standards, plus the FIDO Alliance. The FIDO Alliance stands for Fast Identity Online. It's an organization, an open industry organization that got started in 2013 with the goal of removing the reliance on passwords, basically. And the people that, like the companies involved in the FIDO Alliance are a lot, but to name a few, these are the big names that are part of it. The standardization process, well, it was quite long, but started in 2016. That was when the first working draft was out. From then to the standard reaching a level 1 standard, there were like 11 versions in between. And in 2019, started to get some real tractions big companies started saying, okay, we need to be a part of it. So it was 2019 was a big milestone for this standard. In 2021, it reached level 2, and right now we're already seeing the drafts of level 3. People collaborated on it mostly in GitHub, so everybody could see where the exchanges of ideas and new stuff was coming up. If you are interested and want to take a peek at what the standard is gonna go, that's a good place to take a look. And okay, now we can move on to how it works internally. WebAuthn was the baseline. It's that it gives us a strong possession factor, basically. A possession of what? A possession of a WebAuthn credential, which is something we'll talk about go more in depth in a little bit. But we will possess that credential through hardware devices, either security keys, phones, laptops, hardware devices that will store these credentials for us. The WebAuthn spec, this standard, it's a long document that I'm not gonna bore you with here. So my goal was to try to make it simple for you to understand the several pieces that this technology has. The standard defines 3 things, basically: the WebAuthn credential, 3 entities, and 2 user flows. Let's start by the WebAuthn credential. A WebAuthn credential is nothing else than a good old-fashioned public-private keeper. It has some crucial properties. First one, it's that it's strong because it's public key cryptography, and cannot be it cannot be brute force like password, for example. The other property, which is important to note, is scope. Scope like cookies. It only works for a specific domain. And the most important thing is that it allows, a WebAuthn credential allows us to provide digital signatures and actually prove that we are who we say we are. The entities are 3, the authenticator, the client, and the relying party. To simplify these names for you, the authenticator is the hardware device, the user device, the security key, the phone, wherever, that actually stores the credentials and does the signing. The client is the web browser, and the relying party is our Ruby web server. In a small diagram, on the left you got the authenticator, in the middle you got the browser, and on the right you got the server, and a user below that will interact with these components. The user flows are 2, naturally the registration of a credential and the authentication of a credential. Let's start by the registration flow. Does the video play? I don't know where it ends, so please tell me. This is the registration of a WebAuthn credential done in GitHub. I registered the Touch ID of my Mac and then a YubiKey. Cool. So here's how the authentication process goes for the credentials that I've just registered. Good, thank you. Using the Touch ID as the second factor, I use my password as the first. So behind the scenes, what's going on? In the registration process, I will walk you through this diagram for you to explain what happens. First, the user interacts with the web application and starts the registration ceremony. The browser goes and talks to the server and asks for a bunch of options, configurations, algorithms that are going to be valid for that web app, a challenge, which is a huge token that is going to be used for tampering purposes, and other options as well. The server returns all these options back to the browser. The browser will use the native WebAuthn API built into browsers to talk to the authenticator. And the authenticator will ask for the user's permission, authorization to perform the ceremony, to create a new WebAuthn credential for this site. The authenticator will do so and create a new key pair and return a payload among the public key back to the browser, and the browser will forward that back to the server. The server will now perform validations and verifications on that key, on all that payload. For example, the origin or that the domain matches the one defined at the beginning of the ceremony, that the challenge is the same, the token is the same as at the beginning, and a bunch of other stuff among the digital signature as the most important check. Authentication looks pretty similar, with the difference that we now have stored the public key into our server for that user. So the user flags that he wants to authenticate to the application. The browser tells the server, ask for all the options. Again, same thing, options, algorithms, plus what public key is valid for that user. And the server gets all that to the browser. The browser calls the WebAuthn API with all this, calls the authenticator through the WebAuthn API. The authenticator will ask for the user's authorization for this ceremony, and if the user does that, then the authenticator will create a new signature and send the signature among other payload to the browser to the server, and the server will now perform a series of validations and verifications to see everything it's valid, the signature checks, the origin checks, the domain is the same for the credential that was initially registered, and if everything is successful, the user will be authenticated. How does all that look in code? Well, the server side, it's what we in Cedar Code have been mostly investing in. It's a long set of steps you need to go through to comply with the standard. There's a lot of cryptographic stuff you need to do, among also checking the challenge, the origin, the signature count, because there's a counter that the authenticator, the hardware device keeps, plus the server needs to keep that counter too, and a bunch of other things. So for that, we created WebAuthn, the gem. The gem will do most of the heavy lifting for the Ruby developer. The configuration is simple. You need to put the origin, so the domain of your web application, plus a lot of other configurations you can also add, but the defaults are gonna ensure that you are safe enough and that you are following good security practices as well. You can configure cryptographic algorithms that you're gonna allow. You can configure a bunch of stuff. The registration process will look something like this. I'm gonna use the same diagram on the top right corner to walk you through. Let's say the user starts the registration process. We put a form in front of them that asks them for a username, a nickname for the hardware device, maybe a security key, a touch ID, whatever. That will go to the server. The server will need to give the browser all the options by instantiating WebAuthn credential. If the user is valid, we might want to know if the user is already existing in the system or a bunch of other stuff. So if the user is valid, we're gonna need to store the challenge either in our session or whatever method the developer wants to use to actually keep track of that information through the ceremony. And if everything it's okay, we will go get all these options back to the browser. The browser will call the WebAuthn API through this built-in method, navigator credentials create, passing in all the options to the authenticator. The user will authorize the ceremony, and if everything is okay, we'll resolve the promise and forward all the payload and signature that got from the authenticator to the server. The server will now instantiate a WebAuthn credential with all this information and verify it. That's where the heavy lifting happens and all the steps to do the checks and the cryptographic stuff happens. And if the credential verifies, we are now gonna create a new WebAuthn credential in our database for this user and return a success to the browser, and the user will be registered. The authentication, again, quite similar. We'll put a form in front of the user now to sign in. That will call the server. The server will, again, well, first try to find the user in a sign-in ceremony, probably. Then try to pull all the options. That now will include the allowed credentials for this user, so the public key that we got already stored for the user. We are gonna probably need to store, we are gonna need to store the challenge again in the session or whatever other method we choose. Maybe other options too, depending on the configuration we left. And if everything checks, that goes back to the browser. The browser will now call a different method, but to the same API, navigator's credential create, and pass along all the options plus the allowed credentials for that user. The user will authorize that in the hardware device and will resolve the promise back to the server, which will forward everything back to the server, and the server will now need to perform a bunch of cryptographic checks. Again, everything that needs to comply with the WebAuthn standard. You can use the verify method to do all the heavy lifting for you, and if everything checks, the user will be signed in. Most cases we have seen so far are using WebAuthn as a second factor of authentication, so you still use your password, a knowledge factor, as the first one, and WebAuthn, the possession of a WebAuthn credential, as the first factor. But there's also potentially the option to ask the authenticator, so the hardware device, to perform what is called local user verification. So, for example, the Face ID of your phone or your fingerprint. And yeah, your fingerprint would be an inherence factor that will ask the authenticator to check, or if we, for example, use a security key, we can ask the security key to use a PIN as well. So it will be adding a knowledge factor. In terms of what changes in code, not much. We just need to pass an additional option when we authenticate the credential, which is called user verification required. That will provide us with another factor of authentication. We'll have passwords the first, the possession of the credential as the second, and user verification as the third factor. But for most consumer applications, this is just too much, right? So we could think about removing one of this. But if we are gonna do that, we are gonna probably wanna remove the weakest and remove the password. In such a context, we are gonna end up with two strong factors of authentication, and we are gonna probably go passwordless. Here's an example of a passwordless login registration. I'm gonna register the Touch ID of my Mac. Now I'm gonna sign out and use it to sign in. No password, simple. Awesome. So in this context, we got a lot of wins. Like, there's no possible brute force attacks. We are relying on public key cryptography. There's nothing sensitive being stored in servers or the database. So, it's just public keys, public by definition. Given all what I said about the origin validations and the domain validations, it's impossible to do phishing attacks, and the WebAuthn credential only works for a specific domain. And considering that and the usage of the challenge that is used for tampering purposes, there's no potential of man-in-the-middle attacks. WebAuthn hasn't been perfect, though. There's some challenges on this technology. If we lose the device we have used to register, then we might end up locked out of our accounts. There's no way for us to prove we are who we are. If I want to have portability between devices, that's also a challenge. If I register on my phone and then I want to go to my laptop, like, it's not easy to go from one place to the other. You're probably going to end up having to use a security key that has NFC, add it as another device into your account, in your phone, and then go back to your laptop, sign in, and add your laptop, which is a very hairy process. So that holds back adoption. We need to solve this to accomplish mass adoption. And the way the industry got its way solving this, it's by this name, which is passkeys. A passkey, it's nothing else than a WebAuthn credential. After a few years of WebAuthn, the FIDO Alliance, plus the big platform companies like Google, Apple, and Microsoft came to the agreement to make a big swing and rebranded the WebAuthn credential into something closer than the password term, coming up with passkeys. But it's not just that. There was also the agreement of implementing technology in their existing technology, for example, the iCloud keychain, the Google Password Manager, etc., that could allow the WebAuthn, that could allow these keys, these WebAuthn keys, to propagate across devices through through cloud methods. So passkeys are just multi-device WebAuthn credentials, basically. That's a way of defining them. They also come with a bunch of other great features. Some of them are still work in progress, but autofill for your passwords is already something we are pretty used to use. Well, that's going to come for passkeys, cross-device authentication, authenticators, and clients. This means that browsers need to allow external devices different from the ones that are interactive with a site to use them for registration, authentication, and vice versa. These devices need to be able to perform these tasks for us. Device public key means that in a world where, well, you register on your phone, that passkey is going to get stored in your iCloud keychain, and you're probably going to use that same passkey whenever you go to your laptop and use your iCloud keychain from there. So they're all going to be using the same passkey, basically. And there's a technology that there's a feature that is going to be implemented, which is each of these devices will also have its own public key published to the site, so the site can identify each device on top of the passkey. Are passkeys as secure as device-bound WebAuthn credentials? The answer is no. They are not. They are leaving the hardware device, which is what it's the beautiful thing about WebAuthn. It's that the credential lives in a hardware device that it's in our possession and doesn't live there, doesn't leave that place. But in a range of security, in the range of the least secure stuff to the most secure stuff, we got passwords as probably the least secure thing we can do. Password plus MFA goes a little bit better. Then a long way from there, we got multi-device passkeys, and device-bound passkeys are the most secure thing we can do. But we are fighting against passwords, right? So it's something that has been going on for 30, 40 years. We need to provide a good enough UX so we actually have a chance here. It's a step in the right direction. The registration of a passkey looks a little bit like this. You can see that this is the same site we have used for WebAuthn credentials, but it's going to look a little bit different. Now you will see the pop-up the browser does, and it's prompting us to create a passkey and store it in our keychain. I chose not to, and I asked to give me a QR code. So I'm going to use my phone actually to save the passkey and sign up for this service. The phone already understands that this is a new passkey, and that it's gonna communicate with my laptop through the Bluetooth for actually using the passkey to register. Authentication looks pretty similar. I'm gonna use also the QR code to sign in. My phone will already figure out that this passkey was already registered, and instead of prompting me to create a new one, it will tell me, do you want to sign in with the passkey that you already stole for this site? It's performing local user verification too. So in a context like this, I'm afraid to tell you that Passwordless is coming. Um, this is how support looked like back in 2019. I told you that that was when it was made a standard. So at that point, Apple was not paying much attention to all this stuff. And they realized that they needed to do that and start supporting all this technology in all their browsers, devices, etc. Google was being the best in class. Firefox did a very good start on this, but after a bit lost a little bit of traction. This is how it looks right now. Support, we have good support in all platforms and most of our browsers. So WebAuthn, it's in a very good spot. Passkeys are, as I told you, some features are a work in progress, but I already showed you a very good example of how Apple is working. We also got Microsoft working really well with passkeys. I think the actor that is lagging back a little bit, it's Linux and Ubuntu, but I've been following issues in their issue tracker, and I know they are looking on getting that rolling, so hopefully they will give us support very soon. Since it began, WebAuthn, it was a fun exercise for us to start seeing who was actually adopting this technology, and potentially using our gem to solve all the heavy lifting done in the server. Login.gov was, it's a government agency. They actually, it's not, they're financed by the government, but it's a platform that it's used to authenticate US employees, US government employees. So it was a very good example. They were kind of the first ones to start using WebAuthn Ruby. Google accounts started using WebAuthn as a second factor back in 2019, not Ruby. Shopify started using WebAuthn as a second factor in 2019. And 2 or 3 months ago, they started supporting passkeys. So they are a very good example of how things progressed. 2019, GitHub already started using WebAuthn as a second factor. Basecamp, Rosa added support for Basecamp for WebAuthn in Basecamp as a second factor back in 2019, and she published a blog post about it. GitLab already added support for WebAuthn as a second factor. All these Ruby shops used the WebAuthn Ruby gem. AWS, not Ruby, added support in 2020. I'm sure there are many more companies. I just wanted to highlight a few of them. I want you to leave this talk encouraged to take the step to add WebAuthn to your Ruby applications. With the gem, we try to make it easy for everybody, and believe me that it will be fairly easy if you take the step to do so. We put together a series of blank sheet applications. This is one of them. This is the one that we have used for the demos, except for GitHub, when the demo we did about the GitHub, using GitHub. It's a blank sheet application, just Rails in Stimulus. It's fully passwordless. You can also use this other one we put together, which is going to be using WebAuthn as a second factor, still keeps the password. If you're afraid of taking that out from your users in a single step. So yeah, we also wanted back in 2018. We wanted to see, okay, but how about doing this in a real life application? We need to prove that this will work well. The first experiment we did, the first push we had was to add it to Ruby gems. We started doing that, but the pull request, we did an initial pull request quite big. We didn't get much attention back then. I know that the topic was not as edge as, well, was too edge maybe. It was not as important back then for the Ruby folks that follow all that. So Dorian, an employee from Thoughtbot, actually took it through and created a new pull request based on that, on the old one, and actually added this for Ruby gems. So if you use Ruby gems and have your second factor, you're probably using WebAuthn Ruby. We added it in Mastodon back in, I think, 2018 or 2019. Was a long process, but it's a popular platform right now. If you have a second factor or security key, or a hardware device or phone or laptop Touch ID in Mastodon, you're probably using WebAuthn too. It's a device-based authentication system. So yeah, it's a good example because it uses device, and most applications are probably on device too. So you should take a look if your application uses device as the authentication framework. For the future, the Ruby gem, the WebAuthn Ruby gem is in version 3 right now, 3.0. The standard is still evolving, so we need to keep up with it. We need to adapt to whatever changes in the server-side process of that standard. I always had the idea of having a device extension that will simplify things for people to add WebAuthn as a second factor. I never actually got the capacity to do it myself, but I'm very happy to say that there's a dev called Thomas Cannon that reached out to me a couple of months ago, showing me a lot of things he has done in that space, and also trying to push for passkeys. So if you are interested, reach out to him. I know he needs help. He asked me to tell you that. So if you're interested in helping him, please do. I need to thank a lot of people on the WebAuthn Ruby creation process and all the satellite gems, because WebAuthn Ruby also uses a bunch of other gems that we had to create for it to work. Gonzalo Rodriguez was a former co-founder of Cedar Code. He was kind of the father of this idea. Bart DeWater, former Shopify employee on the payments team, helped us a lot and still does, maintaining all this ecosystem of gems. So we thank you so much, Bart. Santiago Rodriguez, one of our own, has done a lot of work into WebAuthn and the Mastodon pull request, which was quite big. Sora from the Cookpad team and also a Ruby core member did a lot of work around the Apple cryptographic stuff we needed to do at the beginning to support Apple devices. Lucas Garon from GitHub, he did some work on WebAuthn Ruby as well, but another interesting thing he did was to create a package called WebAuthn JSON that simplifies things a lot in the context of the browser. If you want to add WebAuthn to your application, you probably want to check out WebAuthn JSON too from Lucas. And Facundo Padula, another former Cedar coder that did a lot of work too in WebAuthn. So thank you to all of them. I want you to take the step to consider using WebAuthn. So I want to leave you with a bunch of resources to kick the ball and get it rolling. If you are interested in this topic, please check out these URLs. I'm going to publish the slides afterwards, so don't worry if you didn't get them here. Thank you. And if you have any questions, if those resources are not enough for you to understand, or you're still having a hard time on trying to see how to introduce WebAuthn, we also try to help companies adopt it. So reach out to Cedar Code and we'll be happy to try to help you. I don't know, whatever we can do, we'll do it. That's it. If you have any questions, I think I got a few minutes. Else, just play with our demo, and hopefully you will enjoy what you see.